Hello students, welcome to the topic definite integration. We will continue the problem based on fundamental theorem of integral calculus. Now, this is your first question, that is integration goes from 0 to pi by 4 e raised to x bracket 1 plus tan x plus tan square x with respect to x. Let's see the solution. So the given integration I, it goes from 0 to pi by 4 e raised to x inside the bracket 1 plus tan x plus tan square x with respect to x. Students, now inside the bracket that is 1 plus tan square x is there. So, is there any identity? Right. So, well, I can write it. Integration goes from 0 to pi by 4 e raised to x as it is. Inside the bracket, first I'll write the tan x. Plus that 1 plus tan square x, I'll take that in one bracket, right? Because 1 plus tan square x become sec square x, right? So the next step will become integration I goes from 0 to pi by 4 e raised to x bracket tan x plus sec square x with respect to x. Now look at this step. Inside the bracket it is tan x plus sec square x. If I'll consider this tan x as a function, right, and differentiate with respect to x, I'll get f dash x that is equal to sec square x. So your problem will become now integration goes from 0 to pi by 4 e raised to x. Inside the bracket I got function plus its derivative f dash x, and that is a formula in the indefinite integration, that is e raised to x bracket f of x plus f dash x with respect to x become e raised to x into f of x. So here it becomes e raised to x into f of x goes from 0 to pi by 4. So now in your problem the function f of x is tan x. So here the answer will become e raised to x tan x goes from 0 to pi by 4. Now, by fundamental theorem, let us substitute the word upper limit and lower limit. So, if I substitute the upper limit, that is pi by 4, it will become e raised to pi by 4 into tan pi by 4, right? Minus, substitute the lower limit, it will become e raised to 0 into tan of 0. Now, this e raised to pi by 4 will be as it is. What's the value of tan pi by 4? That is 1. So, let us substitute. Now, e raised to 0, anything raised to 0 becomes 1. So minus 1 into, what's the value of tan 0? That is 0. So now look at that, the second term, that is 1 into 0, that becomes 0. So here the final answer I is equal to e raised to pi by 4, right? Now let's see the next question, that is integration of root of 1 minus sine 2x with respect to x goes from pi by 4 to pi by 2. Now see the solution. The given integration I goes from pi by 4 to pi by 2. Root of 1 minus sine 2x. Students, what's the trigonometric formula? 1 minus sine 2a. That is cos a minus sine a the whole square. So shall I substitute here? Cos x minus sine x the whole square with respect to x. Right? This square and square root will get cancelled. So that your integration I becomes goes from pi by 4 to pi by 2 cos x minus sine x the whole with bracket with respect to x, right? Now the problem becomes very easy. Integration of cos x, we know that integration of cos x is sine x and integration of sine x is minus cos x. Let us substitute. So the integration of cos x is sine x, so the first term will be positive. Then integration of sine x is minus cos x, so the second term will become plus. So I'll write it this way, sine x plus cos x goes from pi by 4 to pi by 2, right? Now by the fundamental principle, let us substitute the upper limit minus lower limit. So it will become sine of pi by 2 plus cos of pi by 2 minus, substitute the lower limit, that is sine of pi by 4 plus cos of pi by 4. Now, we know all the values. What's the value of sine pi by 2? That is 1. Cos of pi by 2, that is 0. Right? Sine pi by 4, 1 upon root 2 and cos of pi by 4, 1 upon root 2. Let us substitute. So it will become 1 plus 0 minus, substitute the value. That becomes 1 upon root 2 plus 1 upon root 2. Right? So the first bracket gives the word 1. Then minus, here it will become 2 upon root 2. Right? That 2 upon root 2, I can write it as root 2. So the final answer becomes 1 minus root 2. Thank you.